Hello and welcome to my second scope screencast. This time we are going to talk about functions, how they work, what to do with them, and how cool they are. So let's get right to it and create a problem that necessitates the requirement of a function. Let's say we want to write a program that laughs like Santa Claus. I'm going to write 3 instructions that print a single laughter, and I'm going to execute them. Ho ho ho, and there it is. And now we want to save. Basically, we have written 3 times the same instruction, and at some point, let's say he's laughing a lot more, and at some point you think, you know what, I want to change the way this is formatted. Like the H should always be uppercase, and you're changing all these lines and you're thinking, oh, I wish I only had to write this one time and I could then reference it, and I wouldn't have so much work to do changing all these lines. Look no further, because this is possible with a function. Function always starts with the keyword fn. It's not really a keyword, it's something else, but we're going to talk about that in another video. And then the name of the function. And then a list of arguments to that function. In this case, we're not going to pass any arguments. And then actually the body of the function, what the function is going to do. And in this body we are going to write a single instruction. We're going to move one of these prints into the function, and then we can call that function as much as we like. Let's see what that looks like. Oh, nothing is happening. Why is that? That's because Scopes is a little bit special. If you were passing some arguments to the function, which go here, let's say the function takes one argument and you're passing it here, then the whole line would pass as an expression that takes 2 arguments, because obviously these belong together, right? But if there's just a single one, where it happens so often that you are just passing a single constant or argument in a single line, that you don't want to mean it to be an expression. And so it's not treated as one. If you write this expression, then the parser implicitly understands it as a list. And if you write it as a single one, then it's not treated as a list. So what we are going to do is we could either put them all in parentheses individually, but that sucks. And the easiest way to get the same effect with less effort is just to put a semicolon at the end, which does exactly the same. And this way we are now calling our function, invoking it, so to speak, applying it, and we are seeing Santa Claus laugh. So that's our very first function. What if we want to make it a little bit more interesting? Let's say we're going to change the whole thing into the laughter of a troll, which has different ways of laughing. And going to do that one. We're going to have 3 different kinds of laughs in one function, and every time we call it we get these, so we are going to get 3, 6, 9, 12 laughters. It look like this. And if we want to Let's say we want to change the function with which we print this. Let's say I want to, for some reason, supply a different function that does something with the argument. So I can pass a function to a function. I'm going to do this here. And then we are going to call this function instead. So that now when we call this function, we have to pass a callable function, or we are going to get an error. So in this case, we would, like every time, would pass this function instead. And that would also do the same thing as before. But now we have to pass print in every line, which again would be nice to abbreviate this. So we are going to reconstruct our previous function by calling the more configurable one. And then we can just do this again, which once again is the same. And that's how we pass functions to functions and put this one in a function again. So what if I want to change at one point, let's say the last one, or let's say the first one is supposed to put them all in quotes because, I don't know, at first the troll is still learning to laugh and just trying the different laughters out, and then he has figured it out, and it could be like this. So at this point we can call our more configurable one, and what we are going to do now is we're going to write a special print function that takes one argument, which will be the string we are supposed to print. And then we are going to put this one in quotes. In this case, I have the problem that I want to put a quote in a string that's also delimited with quotes, so I have to put a little backslash in front of it, so to distinguish it from the others. And I'm going to print it like this. And then I'm going to pass my special print function to the laughter function. And you see the first three ones are now in quotes. And what if I'm only doing this once, so why am I writing an extra function for it that's also bound to a name? I could as well write an unbound function that I only use once, so let's do that. I'm going to put the function back right here. And I'm going to remove the name because I don't want to use it again. And that's exactly the same. And that's how we do unnamed functions. Okay, so functions are not only useful for this stuff, but we can also write functions within functions. And what is this good for? This is, for example, good for storing, let's say we have a value that we computed that we want to use more than once. Let's go back to writing a Santa Claus laugh. And we want to make Santa laugh 4 times, like this. But let's make everything 5 times more complicated and try to get as dry as we can. Dry is an abbreviation for do not repeat yourself. And we're going to do it like this. We are going to pass a single one of these to another function that we write in here. And then we are going to replicate this string 4 times. And yeah, we wrote the function, now we have to call it. We can either name the function and call it like this. And that's going to do what we thought it would do. This operator here, by the way, is a string concatenation operator. It's gluing 2 strings together. And yeah, we have the result here. Now this is a bit convoluted and contrived, and nobody wants to write stuff like this. So we can make it a little bit easier by taking out the name and calling the functions directly. For this case, since we want to use the function itself as first argument, we are calling the function and we're passing to it a single argument. So I hope you realize what's going on here. We have an unnamed function that takes a single argument, and we are calling it right away with a single argument. And that's also doing the same thing. But this is still too complicated. We can do it even easier. And this is what we have the let keyword for, which is basically doing exactly this operation, but in a way that isn't so hard to read. We are going to bind this argument to a variable called x with the keyword let, which always starts with a let, then the name of the symbol of the name you want to build, then an equality sign to indicate that now we are going to follow with the assignment, and then the constant we want to assign to it. And then we can take all this. That's basically the same thing. And that has made the function considerably easier. So whenever you see this, what's really going on is that a function here is called with a parameter named like this, and arguments named like this, and these parts that are below this function are basically within that function. Let is just syntax sugar for this process. And that's almost it. Let's do the draw thing again and have more than one variable. We're going to have 3 of them. We're gonna concatenate these strings together. Maybe last exclamation mark behind it for emphasis. And then let's look what this looks like. Yep. And again, this can be written a little bit easier, a little bit simpler. You can assign all these in a single statement and put all the arguments all the names you want to bind on the left side, separated by spaces, and the constants you want to initialize them with on the right side, like this. And then the whole thing is a little bit shorter. And that's it for today. That's functions. I think we've done everything with functions. Have we done everything with functions? Oh, there's one thing that I almost missed, which is recursions. What you would say, what if a function could call itself? Let's have like a function call itself several times. Let's make that laughter, because the problem was we have the Santa Claus laughter like this, and we want to make Santa Claus laugh several times. Like this. But I don't want to write out all these single lines. I would like to also abbreviate this one. And I thought, wouldn't it be nice if I could write a function that would call it once and then repeat the operation. And I could do that simply by have the function calling itself. What a genius move. Let's try that out. Nothing happened. Not exactly sure why that is. You should have at least have seen an error here, which tells you that the function is never returning and is going on forever. So I'm not exactly sure what happened right now. It's possible that the program crashed, which it should, because this function is never returning. Oh, I see now what the problem is. We are never calling it. So we have to at least call it. Let's see what happens. Yeah. Now it's running forever. Laughing and laughing. And the problem is I can't even kill it. It's running so well. Let me just according to this, the program has already ended, but Visual Studio is still printing because we were printing so many laughs that it's now completely, it has stopped. Great. Okay, so let's fix that. Let's have him laugh only like 10 times. We're going to pass the number of laughs we want to have in here. Gonna put them here, store them in n, and we're going to call the function again with n one level smaller, and then we only need a branching so we can tell when to exit. We're going to write an if statement here, which starts with an if keyword, and then the expression we want to test, which should be Boolean, should have a result of true or false. Gonna check if n is bigger than 0. In that case, we are gonna execute the laugh and call the function again, and otherwise we are going to do nothing. Let's check out how that works. And we are going to see 10 laughters, and now it's working. Now we can laugh as many times as we specify, and we have written a recursion, which is also a loop, because all loops are essentially recursions. So what you're seeing here is an if branch, and if is a powerful feature that lets you choose between two different paths to go forward. You can say that in this case we are going to have one optional path that we are going to execute if this expression evaluates to true, but if it doesn't, we're going to just skip the whole block here and continue here. Could like write done here, because that one's only being executed if we are no longer recursing. Let's see what happens. Oh yeah, because they are all returning. That's why that happens. So every time we're calling this function, we're of course returning from this function. And then as soon as we have returned, we are going to execute the next bit here, and every instantiation of that function is going to execute the next bit here. So if I write it like this, we are going to get this result, which we don't want. We want only a single done be printed. So what we have for that is else. This one only applies for the case that n is 0. And we're going to print done for that one. Let's check it out. And there it is. Now it works the way we intended. So if can do this, we can also add another block for another condition. For example, if n is 1, then we are almost done. We're going to execute this part again. We're also going to print almost done here. Let's check it out. Nothing's happening. Why is that? Oh, that's because this first expression is always true first. Like in this case, n may be 1, but it's also bigger than 0. So this is the first block that's being executed. So we are never getting here because this one applies first. So we have to change the order of comparisons. Going to make this one the very first one, which basically never true and always skipped, except for when n is 1. And then we are going otherwise do the second block, and then the third if none of these other ones apply. And now it works the way it's intended. And that's recursions and branches. Okay, so that's it for today. What else? Oh no, we have forgotten one more thing. Return values. Let's say you want to let's say you have a function that computes something and returns it, or we haven't done that yet. Want a function that multiplies two values and adds a third one. Gonna call it multiply and add. Takes three parameters, x, y, and z, and it's going to return the result of an expression that goes x times y plus z. Wanna call that print the result. 2 times 3, 6 plus 1, 7. Check it out. Yep, there it is. And for some reason we want to return two possible solutions. We're going to do two versions. We're going to return x times y plus z, and then we're going to switch it around and return x plus y times z. We're going to return both expressions as two values. Going to print that. Let's see what happens. And we get two values. So that's how you return multiple values. If you return just a single one, you can use a shorthand and just leave out the return, just specify it like this. This works because the last line of a function is always being, the result of the last line is always being returned. Everything that happens before, like if I wrote this here, this would be allowed, but it wouldn't practically do anything. You wouldn't see any of that. It's only returning the very last one. So return can be used if you want to do if you want to return more than one result, but you can also use it to prematurely exit the function. For example, if you find out that, let's say x is 0 or y is 0, and you want to exit the function early because you know that only z matters in this case. And then you can basically do this, return only z, and otherwise you continue with the function. And I'm also printing what I'm doing in the function. Let's check this out. And in this case, we are computing the full result. But if one of the two is 0, then we are going to get only z, and then it's returning here. So as soon as if this block is true, then this is being executed, and this return is being executed, and then return from the function here instead of here. And that's how returns work. Okay, we've come so far, then let's do the rest as well. There's a nice principle that allows you to have functions that are aware of type. We haven't spoken about types yet, so I'm making a short. Let's say you have a function that works differently depending on whether your input arguments are floating point values, are real values, or integer values. Let's say you have a special division function that takes two arguments, a divided by b, and you are going to return them like this. And usually when you divide two numbers, you're always getting a real result. There's also a divider that gives you always an integer result, which is this one. But in this case, we're always getting a real result. So what if we want a division function that returns an integer result if both of the inputs are integer, and if we pass two floating point values, both of the result should be floating point as well. So we want to, for the case that a is an integer, we're going to return we're going to execute the integer operation, and otherwise we're going to return the real operation. Let's see what happens. We execute it now, we're going to get 0 because 2 divided by 3 is can only be represented as 0. We can also do 6 divided by 3, that should give us 2. Right. So what if both numbers are real? What's going to happen then? Then we are going to get, then this part here is going to be executed, and that's doing the other thing. So this can be a bit annoying to write if you know exactly what you want. And so there's a shorthand form to get the same result with a lot less work, which is fn and then 3 dots, which basically means multiple functions with different signatures. So we are going to define a new version of this one, going to comment that out, and going to write different versions of this part of the parameter list. And in this syntax, they are written a bit differently. You write them as with the semicolon separator, then the type that the parameter is supposed to have, then a comma to separate it, because this is very hard to read. And then we can do the same we have done before. For this case, we are going to that one. It's basically matching the types of the input arguments to the options you have made available, and then picking the best one in the order that you have declared them. So what happens now if we call this function? We're going to get an integer result, and if our input values are real, then we are going to get also an integer result, because the priorities aren't right, possibly. Oh no, because I accidentally copy-pasted the wrong block. Let's check this out. Yeah, now it's right. Yep. So this is another way of doing type-dependent dispatch. We're going to talk a bit more about types, what you can do them in another video. And we're almost done. The very last thing we're going to do is variable arguments. what if you have a function that takes where you want to treat, for example, print itself is such a function. You can give one argument to print, and it prints it, and you can give it multiple arguments, and can also print them, and it can deal with as many arguments as you throw at it. And let's say you also want to write such a function. You have that works like this. Let's say we want to have a function that takes these arguments and puts like a message in front of them. Let's say we want to expand print and write in front of every print we want to write such a prefix. So it would look like this. So we write a function print with arrow, and then we are going to take a variable argument list, which works by taking the name of a parameter and appending 3 dots. It could also just be 3 dots, then that would be the name of the parameter. But let's prefix it with something so we know what we're dealing with. And then we just pass this on to print. Then we are going to get the very same result. But if we put an arrow in front of it, then it's doing a bit more. And that's the simplest way to work with variable arguments. You can also do stuff with them like take only the first one, print only the first one. Let's say we assign the first one to a name, like this. And we pick the very first one and store it in there. And we are going only to print this one. That's what this built-in function can do. VA stands for variable arguments, and that's an add to say I want to get an argument from the variable arguments here. I want to get the argument at index 0, and then we are going to store it in X and print it, and then we are indeed only printing the very first one. We can also count how many arguments have been passed and print that one instead. For that we use VA countOff, also variable arguments countOff, then args, and then we are going to see how many of them are in each one. And with that you can write little loops that first count how many arguments are in there, and then it goes through these arguments and does something with them. Okay, so that's everything for today. Thanks for watching, and see you next time.